How do you select sampling time for digital PID controllers? Imagine trying to control a machine with a stopwatch that's either too fast or too slow. Picking the right sampling time is key to making your digital PID controller work smoothly. When you measure signals in control systems, you do it at discrete moments, not continuously. This interval is called the sampling time. Choosing it correctly can mean the difference between a system that responds quickly and one that is sluggish or unstable. First, think about how fast your system reacts. The sampling time should be much shorter than the system's fastest response. A good rule is to set it around 1/10 of the system's smallest time constant. For example, if your system responds in about 1 second, your sampling time should be about 0.1 seconds. This way, the controller can see enough detail to react properly. Next, consider the Nyquist criterion. It says your sampling frequency, which is 1 divided by the sampling time, must be at least twice the highest frequency your system contains. If your system has quick changes or high-frequency signals, your sampling time needs to be small enough to catch those changes without distortion. If you don't, you risk aliasing, which can cause your controller to misunderstand what's happening. Changing the sampling time also affects how you set your PID gains. The proportional gain stays the same, but the integral gain needs to be scaled by the sampling time because it sums errors over each interval. The derivative gain is inversely related to the sampling time, as it estimates the rate of change. If you change the sampling time, you usually need to retune these gains to keep your system stable and responsive. There's always a trade-off. Shorter sampling times improve accuracy and responsiveness but demand more processing power and can make your system more sensitive to noise. Longer sampling times reduce the load on your processor but might cause your control to lag or become unstable. To find the best balance, engineers often start with a sampling time based on the system's response and then tweak it through testing or simulation. Some advanced systems even use different sampling rates for measuring signals and updating control signals. This two-rate approach can optimize performance and resource use. In summary, pick a sampling time that is about 1/10 of your system's fastest response. Make sure the sampling frequency is at least twice the highest frequency in your system. Adjust your PID gains accordingly and fine-tune through testing or simulation. This way, your digital PID controller can accurately mimic the real system, stay stable, and deliver the control performance you need.